Hi friends, myself Kandar Kumar. I am taking power electronics for the electrical engineering students of the fifth semester. In the previous lectures, we are discussing about the various things about related to the power electronics regarding the components which associated in power electronics devices or in power electronics applications and discuss about the various things which are associated with this one in respect of the protection side, in respect of the different types of connections we follow over there. Now we are discussing about the methods of firing which will be associated, how to start the power electronics components like the SCR, UJT, track, diode, GTO, MOSFET, IGBT, NCT, power VJT or power diode or SCR or track. So there will be a different type of method through which we can just turn on the device. So method of firing is indicated as the name that how to turn on the device or how to fire the connection of the J2 junction if in case of the SCR and then when it will be goes to start their functioning as a operation. So in the case of the SCR firing circuit, we have the something which will be relevant for this one. And among this, we are just discussing on the various triggering methods to turn on the SCR. Gate triggering is the most efficient and reliable method. Most of the control applications use this type of triggering because the desired instant of SCR turning is possible with gate triggering method. Let us look on various firing circuits of FCR. First method is the resistance firing circuit. The circuit shows the resistance triggering of SCR where it is employed to drive the load from the input AC supply. Resistance and diode combination circuit act as a gate control circuitry to switch the FCR in the desired condition. As the positive voltage applied, the SCR is forward biased and does not conduct until its gate current is more than the minimum gate current of the SCR. Or another way, we can say that until the resistance, until the current is more than the latching current, then it will be just goes on stop. When the gate current is applied by varying the resistance R2 such that the gate current should be more than the minimum value of the gate current, the SCR is turned on and hence the load current starts flowing through the SCR. The SCR remains on until the anode current is equal to the holding current of the SCR and it will be switch off when the voltage applied is zero. So the load current so the load current is zero as the SCR acts as open switch. The diode protects the gate drive circuit through from reverse gate voltage during the negative half cycle of the input and resistance R1 limits the current flowing through the gate terminal and its value. It says that the gate current should not exceed the maximum gate current. It is the simplest and economical type of triggering but limited for few applications due to its disadvantages. In this, the triggering angle is limited to 90 degree only. Because the applied voltage is maximum at 90 degree, so the gate current has to reach minimum gate current value somewhere in between the 0 to 90 degree angle. As the circuit will be indicated that there is a R1, R2, R3, and the supply voltage will be AC. In between of that one, we are connecting a diode, and the purpose of this diode just to make the unidirectional flow of current, which will be moving from R2 towards the SCR. So it will work as a gate current, which will be the unidirectional toward this side, and the SCR will be turned off until or unless we are achieve the current which will flowing through the gate. It will be more than the latching current, and it will be turned off the device whenever the current from the SCR means from the supply towards from the SCR towards load and return back to the SCR. It will be below the holding current. Then the SCR will turn off. So the operation from 0 to 90 degree, the R resistance triggering will be applicable, but up more than the 90 degree, the we are indicated that the SCR will be turn on. So we at the turning on point will be start from the 0 degree to 90 degree, and the conduction time will be until the SCR is turned on, then up to from this to the up to 180 degrees, the SCR will be under the on state. Right, so this will be the waveform we are finding, that is the shaded part will be indicating the operation of your SCR. Next will be the resistance capacitance firing circuit. The limitations of resistance firing circuit can be overcome by the RC degree circuit, which provides a firing angle control from 0 degree to 180 degree. By changing the phase and amplitude of the gate current, a large variation of firing angle is obtained using this circuit. The circuit triggering consisting of two diodes with an RC network connected to turn on the SCR. By varying the variable resistance, triggering or firing angle is controlled in a full positive half cycle of the input signal. During the negative half cycle of the input signal, capacitor charges with lower plate positive through diode D2 up to the maximum supply voltage up to the maximum supply voltage Vmax. This voltage remains at minus Vmax across the capacitor till supply voltage attains a zero crossing. During the positive half cycle of the input, the SCR becomes forward biased and the capacitor starts charging through variable resistance to the triggering voltage value of the SCR. When the capacitor charging voltage is equal to the gate trigger voltage, SCR is turned on and the capacitor holds a small voltage. Therefore, the capacitor voltage is helpful for triggering the SCR even after 90 degrees of the input wave. In this, diode D1 prevents the negative voltage between the gate and cathode during the negative half cycle of the input through diode D2. So this will be the circuit diagram, which will indicate that whenever we have to just give the supply from the main source, the load current will be continue either from the SCR or from the RC circuit. But whenever the RC circuit is implemented over here, then at that moment the variable resistance will offer a high current, so the charging of the capacitor will be dependent upon the arc until or unless we are getting a specific value of the voltage will be, which will be appear across the gate side, then the current will be flowing through this. Otherwise, the capacitor will be charged with the help of this one, and the charging period will be defined on the basis of the resistance. So whenever the resistance is high, low current will be flowing through this. Time taken by the capacitor to charge up to a specific level, it will be low. Whenever the resistance value is low, then the charging is fast, so the capacitor will be charged fast, and the firing of the circuit will takes place just below the 90 degree. So the timing of the connection of SCR, it will depend upon the combination of the R and C. Over here, D1 will be connected as in the previous circuit. D1 will just give the positive signal to the gate side. D2 will give the protection against the SCR while the supply is reverse bias, then the supply will be moving from the load and it will be in the reversing order. So the triggering, once the SCR is turned on, the entire supply will be moving to the load towards the SCR and return back to the supplying negative point. So this will be the waveform. It will be indicating that the firing will be moving from one point like this up to this point, and the waveform will be conducting from the 0 degree to the 90 degree, 0 degree to 180 degree. So the firing can be controlled from the 0 degree angle to the 180 degree, as in the case of the R firing. We have the option that we can conduct the firing from 0 to 90 degree, but in the case of the RC firing, it can be extended. Next will be the UJT firing circuit. It is the most common method of triggering the SCR because the prolonged pulses at the gate using R and RC triggering methods cause more power dissipation at the gate. So by using UJT, unique junction transistor, as triggering device, the power loss is limited as it produces a train of pulses. The RC network is connected to the emitter terminal of the UJT, which forms the timing circuit. The capacitor is fixed while the resistance is variable. and hence the charging rate of the capacitor depends on the variable resistance, means that the controlling of the RC time constant. When the voltage is applied, the capacitor starts charging through the variable resistance. By varying the resistance value, voltage across the capacitor gets varied. Once the capacitor voltage is equal to the peak value of the UJT, it starts conducting and hence produces a pulse output till the voltage across the capacitor equal to the value point of the UJT. This process repeats and produces a train of pulses at base terminal 1. The pulse output at the base terminal 1 is used to turn on the SCR at predetermined time intervals. So this will be the indication of this one, that the how the value point and the peak point will be achieved, and the firing of this one it will be indicated by the RC, that as we are getting the previous condition where the RC circuit will be there and the R and C combination will be varied to the voltage, but in this case the UJT will be helpful just to meet the number of pulses, because the output of the UJT will be across the R2, and that voltage we are achieving towards the gate side. So that gate side we are getting the value of the VR2 and the current IR2 which will be flowing through this one, and it will be helpful just to turn on the device. So the RC circuit of this one will be helpful in generating the pulse, and that pulses will be varying from 0 degree to the 180 degree. And the RB1 and the R2 and C will be helpful just to discharge the capacitor until or unless the next waveform will be start with the adduction point. Thank you for looking over the lectures which will be discussing about the firing circuit of the SCR. Thank you.